Hello guys, welcome to miniProject. In this video, we'll be looking at a small mini project of measuring your visual reaction time using Arduino. So let's look at what all things we'll learn from this small tutorial. So you'll learn a bit of what is the reaction time. You'll also learn a bit of breadboarding and a bit of Arduino coding. So let's get started and let's have a look at what is the reaction time. So yeah, as we are making a mini project of measuring this time, we should know like what it is, and it is a measure of how quickly an organism can respond to a particular stimulus. And here we'll be talking about visual stimulus, like we'll have two LEDs, and one of them will lit up randomly at a random time, and there will be two buttons to uh, feed in input to Arduino, like which one of them has lit up. So from the time from which LED lights up and you pressing the button, that time duration will give the measure of your visual reaction time. So that's the thing that we are going to measure. And one more thing, like reaction time has been widely studied as it can have great by measuring it we can derive many results. For example, if we have slower than normal reaction time, then it's safer not to drive uh, at that particular time. So yeah, that's all about reaction time. Now let's look at our what kind of hardware we'll need, and what kind of setup we are going to need. So we'll need three push buttons, and we'll need a few LEDs. Okay, we'll need two LEDs, whatever color, whichever color you like. Then we'll need few wires. We are also going to need a few resistors, three 10K resistors to pull down our push button switches, and two 100 ohm resistors for current limiting for LEDs. Then yeah, we'll need one Arduino board. I use Arduino Dimin Leana or something like that, and you can use Arduino Uno or whatever Arduino you have. I mean, the pin compatibilities are there, so no issue with that. Then we'll need one USB A to B converter for connecting your Arduino board to your PC, and we'll need a breadboard. Yeah. So yeah, so that's the part for hardware, and for software you'll need just Arduino IDE, and that will do a job. Okay, so by all those hardware things that I have shown, if you put them together, it looks something like this. So just let me walk you through the circuit connected here. So first of all, we'll connect a 5 volt, uh, just connect 5 volt to this lower rail, and connect ground to the one upper. I mean, these all are horizontally shorted, and from ground we put those pull down buttons for our three switches. They are all and you may know, but let me just tell you that when button is not pressed, this vertical lines get shorted, and as soon as this button get pressed, this diagonal pins get shorted. So when we don't press this button, this connection here at Arduino pin number 2 gets ground, right? I mean, it's pulled down, and as soon as we press the button, this line gets connected to this part and gets disconnected from this side, so it will get 5 volt. So whenever we'll press this button, we'll find Arduino will find 5 volt for that particular pin. So that part finishes off this switch connection, and LEDs are connected, like their cathode are connected to ground through current limiting resistors. Here it's grounded, and anode side is connected to Arduino, where we'll provide it corresponding voltages. So that's a simple construction, and yeah, that's it for building the circuit. Now, okay, so let's go through the code. Uh, at the top, we are declaring these variables. These variables define our pins that we use in our Arduino board, and it's a good practice to define them at the top and don't use magic numbers in the code, so that if you want to make some change and the pin number, just change it here and it will get reflected all over the code. Next variables are up. These variables will be used to sorry to store the state of our buttons, and yeah, as we go through the code, we'll better understand these variables. Next, we have this variables taking care of debouncing. Now, debouncing is a phenomenon in a push button, where when you push a button, the voltage levels doesn't transit from one level to other in a proper way. There are some glitches in between those two levels. These are called that is called debouncing, and we don't want to I mean take those ups and downs as our reading. We want to take the stable state, so we give a delay of 20 milliseconds between uh, where we take the reading. So and 20 millisecond comes like it's generally the debounce period of push button is less than this 20 milliseconds. So that's why we are using this number here. And then here I have kept it as 20,000, and it's in microseconds, so it corresponds to 20 milliseconds. Next up is our variable called rand number, and this is a number that will store the our randomly generated number. And why I'm generating a random number is that random number will act as a seed for selecting which one of the two LEDs we want to light up. And these two variables define the range of that random number. And following variables are kind of changing variables, and we will better understand as we go through the code. So let's look at the main part of the code. Okay, so in the setup part, there's not much. We are just setting up our button pins as input, our LED pins as output. Then we are enabling a serial communication, and in our serial monitor, we'll be using this serial monitor to display the reaction time and popping up some important messages to the user. Then we are just writing, initializing the LED states, and here is an important statement. It says like random seed as analog read 0. Now this 0 specify here the pin number 0 of our Arduino board, analog pin 0, and it is floating and we haven't connected it to anything. So this analog read will read some noise value, and that act as a seed for our random number generator, so that each time we use our board, that sequence is we get various random numbers, so this helps in that. So this code just sets up this part just sets up the random seed for our random number generator. Now let's look at our main part of the code. That's the loop part. Okay, so first thing that we are doing in our loop part is I'm checking this print count number, and if you remember, we have set this print count as 0 at the top. So it will get inside this if part and print this message like print button 3 when you are ready on the screen. On the screen, on the serial monitor. And I will also set this print count as 1, so when this loop gets executed next time, it won't get inside this if loop. And we are also setting up 3 more variables. We are making this take reading as low. This take reading variable is used to whether you want to scan the rest of the two buttons. If it is kept low, then we don't take reading of those two buttons. And these two variables are kept low. odd number and even number. You will understand as we go through why we are keeping them low. Next thing that gets executed in this loop is if button 3 pressed is equal to high, and let's see what we have set it up to. And we have kept it as low at the, we have initialized this to low, so it won't get inside this loop in the first round. So let's not bother it about this part right now. Let's look at the next thing in the sequence. Next thing is we are reading the state of the button 3. Okay, that will, this will just read the button 3. Next thing is if, again there is if statement which compares it to the high, and if you remember we have set it to low right now, so it won't read the rest of the two buttons, and it will come to this part where each reading are compared with each reading with each button pressed are compared with previous button states. Now as we have read button 3 here, so there is only this part which might enable this thing. So like if we have press button 3, then this condition will become true and it will get inside this part. This macro function returns the number of microseconds uh, with a resolution of 4 microsecond from where our board booted up. So this there will be a big number stored inside this last debounce time, and from that time duration we have to wait 20 milliseconds so that the debouncing period gets over, and that is done by using this statement. So after 20 milliseconds it will get inside this loop, and there are 3 if statements inside for each button, and as we have not read this thing, button state 1, so it won't go inside this one, it won't also go inside this part, and it will go inside this part. So here it will see that this if loop checks that the button is pressed, and if the voltage is high, then it will, so if the button is pressed it will say ready. We have wired the button such that if it gets pressed it will go to high, so it will just say ready to go on the serial monitor, and we'll set the button 3 pressed as high and take reading as high. So now those two if loops that we have skipped skipped through, now we'll look at those, and those if loops will now get executed because now we have made them 3. So let's get to that part. So in the next iteration, as pin count we have made it to 1, this part won't get executed, but this part will get executed. So in this part what's happening is we'll just set the LED pins to low, and we'll generate a random number, and if you remember we have set it to 2000 to 5000 in the initial part, and we're also using that random number to give delay. Now there are two things here. We are randomly selecting which LEDs to glow and what time to glow, and the reason see this delay function provides the delay in terms of milliseconds. So that's why I have kept this range as 2000 to 5000, so that I can directly use that random number and provide the corresponding delay. So that so this part will give the random delay to our testing hardware. And next part I'm checking whether this number is odd or even. So I'm just using this odd or even phenomenon to select one of the two LEDs. Now if the number is odd, and I'm checking that random number is odd based on this thing, like I'm bitwise ending it with 1, and if the last bit corresponds to 1, then it's an odd number. So I will lit up one of the LED and I will note down the reading. So this reading is our initial time, so this is the time where our LED lights up, and I will set this odd number as high, and similar with the even number, I will just lit up the other LED and note down the reading and set the even number variable to high. I will again turn down this button 3 pressed as low so that it won't get inside this loop until next time we are ready for the test. Now that LEDs are lit up and time that LED has lit up is saved, it will again take the reading for button 3, but now, this time we are not touching button 3, so there will be just ground at that button. And if you remember, you also set this take reading as high. If you look down here, this thing, so it will now take the reading of the buttons. And let's say if it was an odd button, it was the random number was odd, then it will look for the corresponding button, whether it has been it has that button has got pressed or not. And if that buttons get pressed, and you are quick enough, then it will not quick enough, that if that button gets pressed, it will just get inside this it will go through the similar flow as we went for the button 3, and it will take note down the time where it gets pressed. It will wait for debounce time, and it will get inside this. Let's say button 1 was pressed, and corresponding LED was lit up, so it will get inside this part. It will check for whether that button went high or not, and it will present your reaction time. And the reaction time will be last debounce time minus time 1. This time 1, if you remember, was the time that we recorded when the LED got lit up here. And the last debounce time is the time where we press the button here. So that will give us our reaction time, and similar is the case for LED 2. And finally we'll we are setting up our button states to the current button states. So that's the whole flow of the code, and I think it's a bit cumbersome. If you have any doubt, just mention it in the comment section. I will be happy to reply. Okay guys, thank you for watching. I'm not attaching a demo video in this. Not giving demo in this video. That will make it a bit more large. I'll be uploading it separately, so you can tune to this channel. And if you like this video, you can hit like button, subscribe to this channel. Thank you.